patterns and scatter plots. Open your workbook to page 44, and we're going to start. Today we're going to draw the line of best fit. We're doing bullet number 3. We're going to draw the line of best fit and determine the equation for the scatter plot. Okay, these are the steps that we're going to be using. We're going to plot the points, draw the line of best fit for our data. We're going to calculate the slope, determine the y-intercept, and then write the equation in slope-intercept form. Okay, so the first step that we need to do is we need to plot the points. So while I'm plotting my points, you need to plot your points on your scatter plot as well. A lot of today's lesson needs to be interactive, meaning you're doing it while I'm doing it. So that was my point 1, 3. Remember, x is first, y is second. So that means I go over 1, up 3, over 2, up 6, over 4, up 7, over 5, up 11. Now these are scatter plots, and what that means is that the points aren't going to form a line specifically. Over 6, up 10. But we are expecting these to look like a linear relationship as opposed to a nonlinear relationship, or as opposed to, like some of them yesterday, we had a curve. Over 8 and up 24. That one's going to be off my graph. So I'm just going to kind of approximate here. Let's see. That one would be off the graph. Okay, so there's my points. The next step, step 2, says you want to draw a line that best fits your data. Now in this case, we won't all necessarily draw exactly the same line, but a best fit line, let me give you a couple examples before you draw yours. A best fit line is not going to look something like this. That's wrong. A best fit line, you want it to go through the center of your points. And so like that one there, it's not going through the center. You want it to kind of go in the same direction as all of your points. Let me fix my line here and give you a better example. Let me get rid of this one. Okay, so going through the center of my points looks more like this. Okay, that's a best fit line. That's better. Now, your best fit line technically does not have to go through any points at all. However, it's usually better if it does go through, we said try to capture at least 2 points. So for example, this one here went through this point, but it didn't go through any of the other points. Now, it doesn't have to go through any of the points, but it's better if it does. So if you draw your line and it doesn't, and my recommendation is use a straight edge to draw your line. For example, you could use a book to draw it, or you could use, let's say, your calculator edge to draw the line, because you want it to be nice and straight. Let's see. If you could see another point that it's going through, you're allowed to add a point into your data. For example, it looks like mine's going through this point right here. You can add a point to your data. If you don't want to do that, if it makes you feel more comfortable, then you could just draw your line on purpose so that it's going through 2 points. For example, I could try to make it go through 2 points, like I did right there. Now, it looks like it's going through this point and this point. And the reason why you want it to find 2 points that it's going through is because the next step, step 3, is you want to calculate the slope. And to calculate the slope, you need 2 points. So I'm going to write down the coordinates of the 2 points that it went through. So this point here is 5 and 11. So if you didn't go through one of your data points and you added an extra point in there, you would just write down the coordinates. For example, it looks like I also went through this point, which is 3 and 7. Okay, or that point up there, which was my one that I said was my 8 and 24. But I could also use the 3 and the 7. Or I could use the 8 and the 24. Okay, I'm going to stick with the 3 and the 7 because the 8 and the 24 was kind of a guess. It's not really on the graph, so I'm going to go with the 3 and the 7. Okay, so now I want to calculate my slope. Okay, remember the slope formula is y2 minus y1 over x2 minus x1. Okay, so in this case, that's going to be 7 minus 11 divided by 3 minus 5 for my x's. So 7 minus 11, that's negative 4. And 3 minus 5, that's negative 2. And negative 4 divided by negative 2 is positive 2. So I'm saying my slope of my line is positive 2. Now, if you use 2 different points, your slope might be slightly different. And that's okay. On these problems, we're actually going to get different answers. And that's okay. Answers are going to vary in these problems. Okay, so now I need to get my b. Looks like my b stands for the y-intercept. It looks like it's going to be somewhere in between 0 and 1. Okay, so now to find the b, I'm going to use y equals mx plus b. Okay, m remembers 2. And I'm going to use one of my 2 points up here for my x and my y. I'm going to go ahead, now if you use 2 different points to get your m, you would use one of your 2 points to get your b. So I'm going to use my 3 and my 7. Okay, so I'm using m is equal to 2, and I'm going to use my point x, y. I'm going to use the 3 and the 7. So let's sub that in. So for my y, I'm going to say 7 equals m is 2, and x is 3. Okay, 2 times 3 is 6. So that's that part, plus b. Subtract my 6. And I'm getting 1 for b. Okay, which b is the y-intercept. And I said it looked like it came out between 0 and 1. And according to my math, it comes out to 1. Answers are going to vary again. And it'll probably come out to be somewhere close to 1. Depending on how you draw your line, maybe your line was on a different angle. Maybe yours will come out between 1 and 2. Your slope would be different though, too. Okay, so according to my graph, mine, I got my equation to be y equals 2x plus 1. Answers are really going to vary on this assignment today. So everybody might have slightly different answers. If your slope is different, your y-intercept is different. Answers really vary. Okay, so let's see another example of this. Because they're scattered plots, that's why the answers vary. The lines are going to be a little different, a little scattered. Okay, one thing though that has to be true, let's go back to this one real quick. One thing that has to be true is if those points are going upward, they have a positive correlation. And that means that I should have a positive slope. So keep that in mind. If you got a negative slope, so if you only got a negative 4 but not a negative 2 to cancel out and make a positive 2, then something would have went wrong, which would make your b way off. Okay, so let's look at this one. Let's start plotting your points. So 2 and 12, 5 and 10, 6 and 7. 7 and 6. 9 and 3. 12 and 1. So the first thing I noticed about this one is these points going from left to right, the points are going down. So this one's going to have a negative correlation, which means that when I do my work for slope, I should have a negative slope. Okay, so that was the first step, plotting points. Second step, draw a line that best fits my points. So I'm going to draw my line. Again, this is a bad line. First of all, it's going up. Secondly, it's not going through the middle. This is a better line. Actually, that's pretty good. I just kind of randomly drew that in there. Okay, so that line, going through the middle. It did go through 2 points. So I'm going to want to use that line. All right, this point here that it goes through is 9, 3. So write down your points that it goes through. If your line happened to go through 3 points, or even if the points are closer together, let's say it goes through 4 points, you only need 2 of them. So just pick the 2 that you want it to go through if it happens to go through more. Okay, and that one happens to be 7, 6. And it doesn't matter which one's first and which one's second. Whatever one you decide is first, that's your x1, y1. Whatever one you decide is second, that's your x2, y2. Okay, so now I'm going to calculate slope. And remember with slope, starting with your y's on top. So 6 minus 3 over 7 minus 9. 6 minus 3 is 3. 7 minus 9 is negative 2. There's my negative slope. Okay, so this one's slope is negative 3 over 2. Or, if you prefer, this one's actually a nice decimal. It's negative 3, divide that, that's negative 1.5. If you want the decimal, that's fine as long as it's a nice decimal. Okay, so now I gotta find my b, which means I'm going to use my equation y equals mx plus b. Okay, so for my m, I'll go ahead and use the decimal, negative 1.5. And for my point, my x and my y, I'm going to choose the 7, 6. Remember, that's choice. Use either point. So for y, I'm plugging in 6. For m, I'm plugging in negative 1.5. And for x, I'm plugging in 7. Okay, negative 1.5 times 7. I'm going to grab my calculator, figure out what that is. Negative 10.5. Now, since this is the negative, I'm going to add 10.5 to both sides. That way that cancels out, and I'm left with b, and this will be 16.5. Okay, if we look at our line here, this line, as far as the y-intercept goes, if I keep drawing this line, it's going to go way off the graph here. It probably is going to somewhere cross that y-axis up at 16. Which makes sense with the answer that I'm getting there. Okay, so my answer for my equation is y equals negative 1.5x plus 16.5. Okay, that's all there is for today's lesson. It is a lot of steps. You have to make a graph. You have to make the line. Make sure it captures 2 points, whether the 2 points were already part of the data, or if you have to add an extra point in like I did on this one. Just want to add the extra point in. Use those points to get the slope, then get the b, and then write the equation. Okay, so that's the end of the lesson. If you have any questions, make sure you ask them.